So the question is, how can we get the US Congress to put a price on fossil fuels? The fossil fuel industry has a large influence over the US Congress. Therefore, if we are to have a price on carbon, it had better be on favorable terms to the fossil fuel industry. One way of doing that would be to recycle the revenue raised through a price on carbon back to each individual fossil fuel company so that they can use that revenue to invest and diversify into low carbon energy. So here's a very simple spreadsheet model demonstrating how we might go about that. It's a hypothetical example just for demonstration purposes. I'm using a made-up company called Best Energy Company. At the moment, we can see that there's no price on carbon. Best Energy Company imports oil and natural gas. The amount it imports every month is the equivalent of 6,000 gigawatt hours for oil and 4,000 gigawatt hours for gas. Now that means that with a carbon intensity of 800 tons of carbon dioxide per kilowatt hour for oil and 550 for natural gas, the total carbon going through this company, the carbon content per month, is 4,800,000 for oil and 2,200,000 for natural gas. Okay, so let me just go down to levelized costs and quickly explain what that is. That's the running costs. For example, if the gas is sent to a power station and the power station has to pay for the gas, the power station also has to pay for the maintenance and the workers, and it also has to pay for financing the company, the cost of the mortgage per month. So you can work out that all together and it gives a levelized cost. So I've called it a pre-carbon levelized cost, which means I haven't included the carbon price in the cost here. Later on, there'll be a post-carbon levelized cost, and that will be when I have included the price of carbon. So these are the levelized costs taken from the US Department of Energy. Okay, so as you notice, the table's changed a little bit, a few more figures. We've changed two things. Firstly, we've introduced a price on carbon, and it starts off at $5 a ton, and every year it increases by another $5. The second thing we've done is impose a standard, an emissions reduction standard on Best Energy, and they have to reduce the amount of carbon going through their company by 2% per year. So notice that they're still producing the same amount of energy, but more of it is now coming from low carbon sources. Okay, so we know that the price is $5 a ton. Let's see how that affects the company. The carbon content for the oil is 4 million, so multiplied by 5, that's $20,000. So every month, Best Energy have to come up with $20 million, and for natural gas, nearly 9 million. So if you add those two together, put them into a big pot somewhere, it comes to $28,800,000 per month. So okay, it goes into a big pot, but then, as we said, we're going to recycle it and we're going to give it back to the company again. And we do this by dividing the 28 million between the different forms of energy relative to the amount of useful energy that they make. So you can see there's the 28 million. Only 1 million of it is going towards wind because, they've only put a few wind turbines. Most of it is going towards the oil because that's where most of their business is, and that's 14 million US dollars per month. Okay, so now we can see that we've got some winners and losers. We look at oil here. It paid $20 million, but it only got $14.5 million back. So basically, it's had to pay a cost of $5,600,000. Whereas if you compare it to nuclear, for example, well, nuclear didn't have to pay any carbon revenue, but it received about 4 million. Have a look at natural gas. This is quite interesting. Natural gas only paid 8,800,000, but it actually got back over 9 million. So it actually made a profit of 416,000 there. So the important thing to notice here is what the carbon price is actually doing. And what it's doing is it's making the oil more expensive by giving it a cost. But at the same time, it's making low carbon energy cheaper. Normally, a carbon tax doesn't have that effect. Okay, then we apply the carbon cost to the pre-carbon levelized cost, and eventually it will give us the post-carbon levelized costs. So therefore, we can actually see how this $5 a ton of carbon price has affected the final cost of the energy. One very interesting thing to note here is that if you look at the pre-carbon levelized cost, on average, it's $53,000 per gigawatt hour. And if you look at the post-carbon or the final levelized costs, it's the same as well. So in fact, the carbon price hasn't made the energy more expensive, the overall energy more expensive. It's exactly the same price. And of course, that makes sense really, doesn't it? Because the carbon revenue raised was 28 million, but then all that 28 million was given back to the company as well. So that's the reason for that. Later on, though, we will see that as we progress through the century, the price of energy will get more expensive. Okay, now we're going to look at how the best energy company is going to be affected by a carbon price, by a rising carbon price throughout the century. And here we have the carbon price, and we can see every year it's increasing by $5 a ton. So 2020 it's $5 a ton, 2030 it'll be $50 a ton, 2040 it'll be $100 a ton. The best energy company, they make a plan to get off fossil fuels by about 2080. So the amount of oil they're using and the amount of natural gas passing through their company reduces, but because there is a demand for energy, the amount of energy, I've said, stays the same throughout the century. So therefore they have to increase the amount of wind and increase the amount of energy they create from nuclear because they're cutting back on natural gas and oil. So if you want to look at the spreadsheet model a little bit more, I'll leave a link so you can download it. The spreadsheet model has created some interesting plots though, and let's have a look at some of those. This is the carbon revenue returned. So this was the big pot of money, and then we're returning the money back to the individual departments in the company. And you can see at the beginning of the century, fossil fuels got more of the revenue back because they were producing more energy. But later on in the century, 2060, you can see that low carbon energy received more of the carbon revenue. Okay, here are two more plots taken from the spreadsheet model. This time we're comparing the pre-carbon levelized costs. So that's without a price on carbon, what the levelized costs are, dollars per kilowatt hour between the period of 2020 and 2060. And looking at the same period again, we're going to compare the results after we've applied the carbon cost. So this is the post-carbon levelized cost, dollars per gigawatt hour. We're going to compare the two and see what differences there are. So here we are still moving from fossil fuels to a low carbon future, and it's really represented by the average line here. This is the average price of energy, and you can see that the average price of energy is going up quite simply because wind and nuclear are more expensive than oil. But gas is an interesting one, isn't it? So the Energy Information Agency said that gas prices would increase by 3.1% until 2035. So I've just continued the line up, and it does look like that gas will become more expensive than nuclear and wind around about 2040, yes, or even before. And that's without a price on carbon. So that's sort of quite promising in itself. Okay, so now let's have a look at if we apply this price on carbon, this sort of recycled price on carbon where the revenue is given back to the fossil fuel companies again. And let's see how it affects the levelized costs of these different forms of energy. The first thing to notice, if you compare the two, wind and nuclear energy are coming down in price. That's because of the subsidy which is given by the revenue from the price on carbon. And notice how the price of oil is going up because it has to pay that carbon cost. Here it doesn't have to pay the carbon cost, but here it has to pay the carbon cost. So you add that on to the levelized cost to get the post-carbon levelized cost. So you can see that the price of oil is getting more expensive, whereas gas will be pretty well the same price as wind and nuclear around about 2030. Around about 2040, oil will be the same price as nuclear and wind. Personally, I think it will happen even earlier than that because oil prices will start to go up quite rapidly as it gets more difficult to take it out of the ground. Once again, have a look at the average price of energy, that's the purple line, and you'll see that it's exactly the same as for the pre-carbon or non-carbon levelized costs. So what that means is that with or without a price on carbon, in this case, the average cost of energy, the average rise in the cost of energy is exactly the same. So just to throw some numbers at you, the average energy cost increase between 2020 and 2080 is 1.5% per year. So that's the average cost, that's the purple line. However, for a short period between 2030 and 2040, oil costs are shown to rise at 4.72% per year. So that's quite high. And you can see that's here. That's the oil price is going to be rising pretty quickly here. But once we get to 2040, then hopefully we'll change our ways and we'll be driving electric cars powered by wind or powered by nuclear energy. I know it takes a little bit of time for human beings to change their ways, but it's probably a good thing that fossil fuel prices are going to rise because it'll actually make us change our ways and go out and buy an electric car, etc. So by comparison, the US Energy Information Agency forecasts average fossil fuel prices to rise by about 2.44% per year between 2013 and 2035. So 1.5% increase, it's not really such a big deal. So, just to summarize as to why an internalized price on carbon would be so good. Firstly, the fossil fuel companies will prefer it over other types of prices on carbon, quite simply because they get the revenue back, and that will literally save them trillions of dollars over the century. And secondly, the most important thing is that an internalized price on carbon reduces the price of low carbon energy, meaning that they become cheaper than fossil fuels earlier than would be with the other types of carbon pricing.